Need to present on behalf of ValThera our breakthrough transcatheter tricuspid valve replacement for the treatment of tricuspid regurgitation. Here's our team. At the bottom, a very experienced business and engineering team, and on top, a medical team with really experts, KOL, and innovators. And everybody shares the conviction that the ValThera technology is the technology for tricuspid regurgitation. TR is a large unmet need for treatment with 400 to 500,000 patients per year between the US and the EU per year appearing. And TR has major consequences, mortality and morbidity. And unfortunately, the surgical treatment and even the current interventions have bad results, residual TR, or complications. So our team, the value proposition is to raise 3 to 4 million to do the preclinical and to reach the state of first in human. This is the panorama of therapies for tricuspid regurgitation, and I will not go through every single word, but suffice it to say that the repairs have too often residual TR that plays a role in poor outcomes. The small prostheses are too wobbly, and the large prostheses, which is the most of what we have, are way too bulky, too large, and too traumatic to the right ventricle with bad outcomes. This is the schema of the only approved current prosthesis, and on the left it looks nice and snug, but on the right shows the reality because it's a very bulky device that has to go above and beyond the lesions on the tricuspid valve, and therefore there are clinical complications with trauma to the right ventricle, causing RV dysfunction, causing atrioventricular block. The system is very rigid, causing perforation and canting. And because of the size, the large size, the flow is slow, causing thrombosis. Conversely, our prosthesis, if we start from the bottom, anchoring is at the level of the ventricular septum. And because of that, we have no interaction with the annulus or the RV, no AV block, no RV dysfunction, no prosthetic dislodgement. If we go one above, the prosthesis has a slim conical design that will lead to acceleration of flow and lack of thrombosis. We have a supraannular positioning so that the native leaflets are covering the frame, and you can see them here covering the frames and prevents leakage. And the whole system is nimble, steerable, and therefore there are no perforation, no complication with the delivery device. So when we look at tricuspid regurgitation, we look at from the right atrium, and you see the tricuspid valve here, and the defects are often very large with leaflets that are not even touching and are producing very large jet of regurgitation. And we approach for intervention. We can come from the superior or the inferior vena cava. We approach the tricuspid, enter a sheath to the right ventricle, and insert 1, 2, and then 3 anchors that are related to tethers that are now going to be guiding the prosthesis in position, adjustment, and locking in position. And as soon as it is there, it allows the flow through the prosthesis in the right ventricle. And as you can see, it does not interfere with the right ventricle, and the right ventricular contraction and the conduction is normal. So that's how we obtain great clinical outcomes. Our testing is on the bench. We have 3 sizes, so we can address any type of tricuspid regurgitation. And you see the valve in the pulse duplicator or in a revived heart, and it's functioning immediately normally. And we did a 1 million cycle testing without any breakage. We did a transvenous animal implant. On the left video, left, you see the approach to the right ventricle. On the right, you see the anchors placed in the septum and the prosthesis in the tricuspid valve. We did a complete transvenous approach, full anchoring, full crimping, successful intracardiac locking, so that the path to a complete transvenous system is well defined. We did another implant, which is a surgical implant, and on the left, you see the fluoroscopy with the anchors in the septum, but in a different position, so it's very, very versatile. In the center, you have the echo, and on the right, you see the overlay over the echo, showing the right ventricle contracting fully normally and showing the flow through the prosthesis, accelerating and washing the leaflets so that there is no thrombosis. So the concept, the anchoring, the delivery, and the prosthetic implant perform impressively. The technology is versatile, superior vena cava, inferior vena cava, anchoring and implant positioning, so that the path for an all-in-one device is well defined, and with that, we hope that we'll be able to treat in any hospital, any type of tricuspid regurgitation by any interventional cardiologist. IP is protected. We have a patent in Japan and in the US and soon in Europe. And the regulatory is relatively simple. There is a DRG, there is a CPT code, and to validate, we'll need only a one-arm clinical trial, not a randomized clinical trial for approval. The recent completed acquisition were with large valuation, and we do hope that we'll reach or surpass those valuation. And here is what we intend to do. So the third line is showing that we need to build for our long-term animal testing, do the long-term animal testing, and then promptly go to the first in human, where most of the exits were noted. So this will be generating strong multipliers. So in summary, we serve a very large clinical need. The current technologies are unsatisfactory. We have a nice supraannular design which is safe and effective. ValThera success in the current implants imply prompt completion. And the TTVR has already a DRG, and we believe that there have been satisfactory exit and that we can probably equal that within the next 5 years. Thank you so much for your attention.
Turn it over to you.
Thank you very much. That was a great presentation. If you could give me a little bit more information around your ease of adoption and learning curve. What do you anticipate compared to current technologies?
Ease of adoption, you know, my buddies, interventional cardiologists, some are absolutely fixated on a